Next up, inflammation. We're going to talk about the characteristics of inflammation. We're going to talk about permeability of blood vessels and migration of phagocytes. First off, inflammation is something that we've all experienced, and it is a non-specific response to tissue damage. You can get it from spraining your ankle and having microbes invade and cause an infection. All of it results in inflammation. Because this is a microbiology class, we're going to be talking about microbial causes of inflammation. Now, what you experience is redness, or in Latin rubor, localized heat, calor, swelling, edema, pain, dolor. All of this is caused by permeability of blood vessels. That's the first part of inflammation. Those blood vessels become leaky, and fluid leaks into the tissue, leading to swelling. Now, because this fluid has come from further inside of the body, it's warmer than your skin, and it also causes a red flushing of the skin. And because the swelling can press on nerve endings, oftentimes that's what causes the pain. Now, the real reason for the permeability of the blood vessels is to aid in the migration of phagocytes out of the blood vessels into the tissues where the tissue damage is happening. Now, eventually, after the phagocytes have cleaned up all the damage, inflammation leads to tissue repair. Now, inflammation comes in two kinds. Acute, which is a very brief response to tissue damage. Permeability of the blood vessels, you get the phagocytes in, they clean up the pathogens, they clean up dead cells, and then you move on to tissue repair. Chronic inflammation has been linked to many diseases, from everything from arterial sclerosis and heart disease to periodontal disease to Crohn's disease, which is an autoimmune disease of the intestines, to lupus, to you name it. So it's not good for inflammation to last for long periods. But for acute, it's very useful and helpful to the body. Let's talk more about permeability of the blood vessels. So this is what a little venule, a little vein before it hits the capillaries normally looks like. You have your epithelial cells tightly packed, and you do get a little bit of leakage of fluid. That's what causes interstitial fluid, the lymph, bring nutrients, oxygen, to the surrounding cells. The blood cells stay inside. Now, once we get inflammation, which stimulates these epithelial cells to round up and pull apart, we get more fluid, more antimicrobial chemicals coming out. Monocytes are stimulated to attach to these epithelial cells and squeeze out in the process of diapedesis, all of which leads to getting what's needed to the damaged tissue. There are several types or classes of molecules that lead to the permeability of blood vessels. In other words, they are inflammation mediators. Bradykinins are produced during blood clotting. So if you have damage to the tissue, either mechanical damage, say you cut yourself, or from pathogens lysing cells, then bradykinins are released, and this leads to inflammation. Prostaglandins and leukotrienes are both produced by patrolling macrophages when pathogens are identified. Now, I will mention that we do have products for suppressing both of these. So if you've ever taken aspirin or ibuprofen, Tylenol, these are antiprostaglandins that limit or prevent inflammation. Now, histamines. We've talked about histamines. You've probably experienced histamine release. It is released by basophils, platelets, and mast cells when they're exposed to complement. Also, it's released when basophils, mast cells are exposed to antibodies. Now, we have antihistamines, and these act by blocking the receptors on blood vessel walls for histamines, and it reduces the inflammation, usually of what's happening in your nasal cavities that cause you to feel like you've got a continual cold. They're also effective in helping with mild bronchial spasms that are caused by histamines. But enough about histamines. All of these lead to migration of phagocytes. Phagocytes are attracted by concentrations of complement 3A, complement 5A, leukotrienes, which are signals that are released by leukocytes, microbial components, toxins. All of these will stimulate marination, which is adherence by these phagocytes to receptors in the blood vessels. Now, neutrophils are the first responders. They have a tendency to show up at the site of inflammation first. After that, we get monocytes, which arrive later, and they mature into macrophages. Now, they can be wandering macrophages. Sometimes they stay in that particular area. All of which leads to them devouring pathogens. That's a good thing. So the last part of inflammation is tissue repair. Because of the permeability of the blood vessels in the area, we get a flood of nutrient and oxygen to the damaged area, as well as phagocytes. So once the pathogens are cleared out, once the dead cells are cleared out, then undifferentiated cells, we usually call these stem cells, can go to work on tissue repair. If there's not a whole lot of damage, these undifferentiated cells can repair the tissue so that you can't even tell. If there's been a lot of tissue damage and the repair has to happen quickly, we have fibroblasts being involved, and this leads to scarring. There's a lot of scarring that can be a problem. A little bit of scarring, not so much. Now, if you have damage to slow dividing cells, then the tissue tends to remain damaged for a long period of time. This generally happens with neurons and heart muscles. So when you have inflammation in your nervous system, your brain, or in your heart, this leads to long-term disability. Now for our last topic, fever. Many of the chemicals that are secreted by phagocytes that stimulate inflammation also stimulate fever. We call them pyrogens. Also, there are some bacterial toxins or antibody-antigen complexes that are also pyrogens. These travel through the blood to the hypothalamus, which is this little part of your brain. The hypothalamus regulates your metabolism, including what your core temperature is. So it releases prostaglandin. Now you remember that prostaglandin is also an inflammation mediator, causes dilation of blood vessels. This resets the hypothalamic thermostat. So in other words, your core temperature goes up. This is what we call a fever. So this causes shivering, a higher metabolic rate, inhibition of sweating, which leads to increasing your core temperature, and vasoconstriction. In other words, you've already had inflammation to the area. We're causing vasoconstriction in other areas so that we can keep the heat in the core. This increases the body temperature to the higher point, which is fever. Now, the question is, why do we have fevers? Well, this higher temperature does a number of things. Remember back to the chapter on growing organisms? Many pathogens, their optimal temperature is 37 degrees Celsius. They're mesophiles. And quite a few pathogens have a very narrow optimal range. If it gets too warm, it slows down their growth. Now, on the other hand, your phagocytes, your neutrophils, etc., operate better at a higher temperature of a low-grade fever. So in other words, their optimal temperature is higher than the pathogens. So they're kicking into high gear and the pathogens are struggling along. Also, this causes your hemopoietic cells to divide more rapidly, so you get more blood cells. All of this aids in the recovery process. Now that's for a low fever. Once you get to a high fever, generally for adults that's considered 103 to 104, then you want to start worry about bringing that fever down. Things have gone too far and you start affecting the functioning of the brain. In fact, if you get a high enough fever, you can go into convulsions and after that coma. It's not good. So what do we do to lower temperature? Well, we take antiprostaglandins. Brings the fever back down. But if you have a low-grade fever, especially if it's for a short amount of time, it's good to let it go because it's aiding the battle against the disease. Well, that's it for this topic, and that's it for this chapter. There is a lot. And here are several reminders of what the learning objectives are.